In this problem, what we're going to be talking about is we're going to talk about ideal gas law and the density of a gas. The gas or the vapor we're going to be working with is going to be diethyl ether. It used to be used a long time ago in starting fluids of carbureted cars. Since we have electronic fuel injection, there's no need for a carburetor, so this isn't used all that much. But with older cars that happen to have carburetors, or lawnmowers, or tractors have a hard time, gasoline tractors have a hard time starting, diethyl ether is used as a starting agent because those typically have carburetors. So the question reads as such: diethyl ether vaporizes easily at room temperature. If the vapor exerts a pressure of 233 millimeters of mercury at a temperature of 25 degrees Celsius, what is the density of the vapor? Now, a couple things we have to do here is we got to do some conversions. We can convert this into atmospheres by 1 atmosphere is equal to 760 millimeters of mercury. So millimeters of mercury will cancel. We're left in units of atmospheres, and this is going to give us 0.307 atmosphere. Likewise, the temperature, we've seen this before, we had 273.15 to this, so this gives us 298.15 Kelvin. And as I mentioned, we're going to be working with PV equals nRT, right? So we take PV equals nRT. But recall that density is equal to mass all over volume is what density is. But we don't have a mass in here. But if we take the number of moles and we multiply that by the molar mass, that's going to give us a mass. So we multiply the entire quantity by the molar mass, such that we get the molar mass times pressure times volume is equal to, now if you take the number of moles and you multiply that by the molar mass, that's going to give you the mass, RT. Now, if we divide by volume, what we end up getting is we get the molar mass times pressure is equal to, this becomes M all over V, RT. We then can move the RT over to here, such that we have MP divided by RT, and that gives us mass all over volume, which is equal to density. So we can find our density now of this gas. So density is equal to the molar weight. Now the molar weight of diethyl ether, you simply add up, there'd be 4 carbons, 10 hydrogens, and 1 oxygen, and that comes out to be 74 grams per mole, times the pressure that we have, which is 0.307 atmospheres, divided by R, which is 0.08206 liter atmosphere mole Kelvin, times our temperature, which is 298.15 kelvins. Now, if we look at the units, I'll do that in a different color so you can see how that works. So our kelvins will cancel with the kelvins, our moles will cancel with the moles, our atmospheres will cancel with the atmospheres, and now we're left in units of grams per liter, grams per liter. And when we do this arithmetic, what we end up getting is we get 0.927 grams per liter, which is a very, very small density when you consider it. For instance, the density of water is going to be 1 gram per milliliter, or 1,000 grams per liter. And so this is approximately about 1,000th smaller than the density of water. But that makes sense because this is a vapor and water would be a liquid. But how you can come up with the density for the ideal gas law is you simply multiply everything by the molar mass, and recognize that when you multiply these two terms together, you actually get the mass. You get the mass. And then the mass divided by the volume, which I have here, is going to be density. and then you just move the RT over, and you got density is equal to the molar mass times the pressure divided by the ideal gas constant, R, and then divided by the temperature in Kelvin. If you have any more questions on the ideal gas law, please let me know.